So a reminder, today we will start working on, once I go over 3.9, 193 and 194, we'll then start on our review for Chapter 3, and then we'll go over Chapter 3 review tomorrow to have a test on Thursday on Chapter 3. I think you're all going to do very well on it. And then on Friday, we will kind of just, think about how to put together our full sheet of paper to put whatever we want on our full sheet of paper for the final exam for first period is a week from today. I guess second period is Monday, I guess. I don't know. So, I don't know. We'll figure it out. All right. How'd this homework go? Do you feel comfortable with it? Okay, obviously we're combining different things. Assume we have apples with a weight of 85 grams, standard deviation of 12. We also have oranges that have a weight of 100 grams, standard deviation of 16. So we have apples and we have oranges. Apples mean 85. Standard deviation is 12. Oranges have a mean of 100 and a standard deviation of 16. Good so far? Dude, you're just writing stuff down. Okay. Well, hi. We're just going over page 193. All right. Find the mean and standard deviation of each. The total weight of an apple and an orange. So this is from problem number 1. 1A. Apple and orange. Okay, so if we have apple and orange, we will add the means together to get 185. And then, hey, question. So this is the new mean of the combined apple and orange. How do I find the standard deviation? What's different on the standard deviation? The apple and orange means are easy. We just add them together. But what do we do to find the standard deviation if we have two different standard deviations from two different items? Who remembers? Yep. So I go 12 squared plus 16 squared. Add those together. So anyone have that worked out? Does this come to 400? Is that what it is? So this comes out. So it comes out square 400 is 20, right?
Yeah.
Okay. All right. So the big thing to remember is when we're doing that, this will be the standard deviation of apple and orange. Okay. Hey, I was sitting in front of you. All right. What's the difference in weight? So what's the difference of the apple and orange? This is B. So the apple was 85, the orange was 100. So is it okay that we get a negative number here? Sure. So that's the difference between the two. And then letter C, what is the total weight of 5 apples? So 5 times 85. 5 times 85, let's see, that's 25. Carry the 2 for 425. And then the total weight of 2 apples and 2 oranges. So 2 apples is 425. Or wait, I did that wrong. Sorry. 2 apples is 170. 2 oranges is 200. So we're looking at 370 grams. And then find the difference in weight between a bag of 3 apples and a bag of 3 oranges. Okay, so letter E, 3 apples minus 3 oranges. So 3 apples, 240, 255, minus 300, which gives me negative 45. Okay, that's basically all you got to do on that one. Okay. All right. But so that right there is a real good common error, because what did they ask us to find on number 1? We want to find the we wanted to find the standard deviation of each. So though I've done this, it's not necessarily done yet. So the difference in weight between an apple and an orange is the negative 15, but we have to, so this is the new mean, okay? But I have to find the standard deviation, which is going to be root 85, or because we're just subtracting it, this would have the same standard deviation as the 20, okay? Letter C, this is our new mean. Wait, letter C, 5 apples, 425, we have that. The standard deviation of 5 is going, so this is the new mean here, but the standard deviation is going to be root 85 squared times 5. And I'll just grab the calculator because I can't do it in my head. Hopefully these bad boys will take care of that. Here. Root 85 squared times 5. So this comes out to, ooh, I'm off. Okay. So why am I off? Letter C. Bless you.
So it should use 12 instead of 5.
Do what?
12 instead of 5.
Oh my gosh. Oh my gosh. Thank you. Oh, I knew I was amongst greatness with y'all. So 12 squared times the 5. There we go. Nope, that's not where. Oh my gosh. Come on. 12 squared times 5. Close that. There we go. So the standard deviation of this is going to be 26.8. And then letter E, find the difference of 3 bags of apples. So the minus 45, this is fine for our mean. But then if we're finding the standard deviation of the two, so we're going to do root 12 squared. How many apples we got? 3 apples plus 16 squared times 3 oranges. Uh-oh, we're getting in some troubled grounds here. 12 squared times 3 plus 16 squared times 3, close parentheses, and I'm off. 12 squared times 3, that's 432, plus 16 squared plus, times 3, so that's 768. So 432 plus 768, and then take the square root of that. All right. So Mr. Anderson's answer doesn't agree with mine. So cool. Hang on. I just want to see if I did something incorrect. Nope. For the standard deviation, though, did I have that yesterday? Okay, so square root 336. No, we're just off. I don't know. I'm off a little bit. I don't know. 28.28.
Because you told me yesterday this is the way you set that.
Yeah. Yeah, that's what I just did.
Right.
Yeah. I don't know. All right, problem number 2. Create shaded bell curves and calculated commands. 1 apple and 1 orange is selected. What is the chance that the apple weighs more than the orange? So then I'm going to go A minus B is greater than 0. So the apple weighs 85. The orange weighs 100. So then we kind of come up with this. Negative 15 is greater than 0, which is kind of obscure. So when we are looking at this, we have to create our normal distribution. So I'm going to go, this is our mean that we're going to deal with. And then what we're going to do is we're going to create our standard deviation. So the apple is 12 squared plus 16 squared. So 12 squared plus 16 squared. It's 400. So this is going to give me just 20. That's our standard deviation. So if we do our normal CDF on this, or our normal distribution, we're going to jump into our friend Desmos. Come on, baby. Graphing calculator. Normal distribution. And I forgot what my stuff was. We have negative 15 and 20. So negative 15, comma 20. If we hit plus, we'll see our normal distribution. So what we're looking for is we're looking for the region of the area from 0. So that's where it starts going positive. So we're going to go from 0 to infinity. So in this case, we have a 22.7% chance that we're going to get an apple that weighs more than an orange. Okay? And the reason why you set that up with the negative, that's going to help you with those things. Okay? And then we want B, 2 apples that have a total weight greater than 200. So the mean in this case, the mean of the apples is 85 plus 85. So we're going 160, 170. That's what our mean is. Our standard deviation will be 12 squared plus 12 squared. So that's root 288. So we have a standard deviation of 16.97. All right, so then we're going to change our normal distribution to what they have, 170 and 16.97. 16.97. And my other one was, I just forgot 170. All right, so then we want to know what's the probability that it's greater than 200. So we have 200, hit the plus thing. So you're talking about a tiny area. So if you have 2 apples selected, what's the chance that you actually have a weight greater than 200 grams, where 2 of them would normally weigh 16 or 170 grams? So we have a 3.9% chance that 2 of our apples, if we grabbed them randomly, would be over 200 grams. All right, and then 4 tasks are presented, normally distributed with the average standard deviation. This is page 194. All right, we have tasks A, B, C, and D, average time, standard deviations. What is the probability that task A, so task A will take more time than task B, so I can go A minus B is greater than 0. So on our normal distribution, we're going to have 0 here, so we're looking for this shaded region is what we're taking into account. So task A has a mean of 12, standard deviation of 2. Task B has a mean of 8 and a standard deviation of 2. So if I go 12 minus 8, this will be the mean we're looking for. So this is the mean that we're going to plug in. And our standard deviation is going to be 2 squared plus 2 squared, which is root 8. And root 8 is 2.83. So we want to make this on the bigger than 0. So this is going to be a pretty high probability. 4 and 2.83. Cool. Got it. So I'm going to change my normal distribution to go with what they've said. We have 4 for a mean. We have 2.83 for a standard deviation. And we want to know, we're going to go from 0 to infinity. If I hit the plus, so that's where we're taking place. So we have a very good probability that in this case, that task A, we have a 92.1% chance that task A will indeed take longer than task B. What is the probability that task C, so then this is still from number 3, so this is number 4, excuse me. We're going to say that C will take longer than D, so realize that C minus D is greater than 0. So the mean of C is 10. Standard deviation is 3. Task D, the mean is 18. Standard deviation is 4. So we want C minus D, so 10 minus 18. So we're going to put negative 8 in. That's our new mean. And then I'm going to find my standard deviation. So 3 squared plus 4 squared. So that's 9 plus 16, which is root 25, which is 5. That's our new standard deviation. All right, so negative 8 and 5 we're plugging in. Negative 8 and 5 plus, and so task C will be take more, so we're looking for where we're greater than 0, like we had posted. So that area there, so we're looking at 5.48% chance that this will take place as far as our tasks. And what is the probability task D will take longer than task B? So we're just kind of hammering through a bunch of this. So D will take longer than B, which I'm going to go D minus B is greater than 0. So we're looking greater than 0. So task D, we know our mean is 18. We know our standard deviation is 3. Task B has a mean of 8 and a standard deviation of 2. So my new mean is going to be 18 minus 8. So we're at 10. That's the mean we're going to plug in. Standard deviation is 3 squared plus 2 squared. So that's 9 plus 4. So root 13. Root 13 is 3.6 roughly. Is it? Is it? Oh, thank you. 4, that's 16. 16 plus 4, that's 20. Root 20, thank you. 4.47. There we go. All right, so now I can go ahead and do my normal distribution on this. So I'm going to plug in 10 as our mean. Standard deviation is 4.47. hit plus. So the probability that this takes place, that task D will indeed go longer than task B, is 98.74%. So it's very likely that that will take place. Very unlikely that the other one will take place, that B will be longer than D. And what is the probability that all 4 tasks will take longer than an hour? All right. So all 4 tasks. So A is 12 and 2, B is 8 and 2, C is 10 and 3, D is 18 and 4. So those are the means and the standard deviation of each. So we want to know what's the probability that A plus B plus C plus D will take longer than an hour, so greater than 60 minutes. Okay, so I got 12 plus 8 plus 10 plus 18. So that's 20, 30, 48. So this is our combined mean of everything. Our combined standard deviation of everything is going to be 2 squared plus 2 squared plus 3 squared plus 4 squared. So 4 plus 4 plus 9 plus 16. So that's 8, that's 17. 17, is that 33? So root 33. So we have a combined standard deviation of 5.74. All right, so 48 and 5.74. So we want 48, comma 5.74. And we want to know its probability that they will go longer than an hour. So we're talking about, move decimal 2 places to the right, so 1.83% chance that all of our tasks, if we did all of them, would take longer than an hour. And then the last one's a little more complex. Number 7, what's the probability that A plus B will take longer than C plus D? So then we can realize that this is A plus B minus C minus D is greater than 0, just using a little bit of algebra. So A is 12 and 2, B is 8 and 2, C is 10 and 3, and D is 18 and 4. So 20, so 12 plus 8 minus 10 minus 18. So the new mean is going to be -8. And the new standard deviation, we just found the standard deviation is 5.74. So 2 squared plus 2 squared plus 3 squared plus 4 squared will come out to 5.74 is the new standard deviation. So now we're looking for greater than 0 again. So 5.74. Going into Desmos, our friendly buddy. So we're going to go -8, comma 5.74. Look on that, and we want bigger than 0. So we have a 8.17% chance that if I did task A and B, that would actually take longer than tasks C and D. So, questions for me. Obviously, Desmos heavy. The standard deviation is the goofier thing to write down. So, would you all take the opportunity to do page 195, 196? This is the review in which we will go over in its entirety tomorrow. And then hopefully you get your half sheet all set up for the quiz that'll be on, or the test that'll be on Thursday. Cool? Everyone happy?